Okay, so we're going to be doing a little video going through some of the maths things that you need for iGCSE biology. This would also work for Nat 5 biology as well, and it would cover the math skills you needed for all different specs. So let's look at some past papers. These are taken from Edexcel past papers. Just to show some of the skills that you'll need. Let me just get my pen. Okay, so the largest neuron in the human body passes electrical impulses from the base of the spinal cord to the muscle in the big toe. This neuron can be up to 1.3 meters in length. An impulse passes along a neuron at the speed of 1.2 times 10 to the power raised to the power 2 meters per second. Calculate the time taken in seconds. So, firstly, let's just look at this number here and discuss significant figures. So 1.2 times 10 to the power 2 means 120 meters per second. So this 2 means that there's your 2 places from this decimal place. So if we had, I'll just write over here, say we had 3, 1, 2, 4, 5, 6, and we wanted to write it in this notation and simplify it, we'd want to 1, 2, 3, 4, 5, 6. That'd be 3 times 10 to the power 6. If you had 4 point, no point. So we could write this as 4.56 times 10 to the power 6. But we'll keep revisiting this whole idea of significant of scientific notation because it keeps coming up. Okay, so that's the first thing. Now on your calculator, if you should have a number that either says exp or it might be EE. So if you were to write in 1.2 and then EE or exp, then you might get the B10 and then you'd put a 2 to raise it to that power. So the next thing to note is this is about speed. So you need to know this formula that the velocity or speed is equal to distance over time. Now if you can't remember this is the velocity here, it's in meters per second. So meters per second is something like that, and that's like a dividing sign. So the speed is the meters divided by the time in seconds. And with these questions, always pay attention to the units. So here it is in meters per second, and you're given the length in meters. The units have to be the same. If this was in millimeters or in kilometers or in any other unit, you need to put it, the length, the distance, into meters so that it works. Same goes for time. Time has to be in seconds. So a little way to also remember this is if we draw a triangle, velocity is distance over time, and so distance is velocity times time, and time is distance over velocity. So we want to find out the time taken for this impulse to travel. So we're going to have to rearrange our formula. And we can do that by using our little triangle here. So what we want is time. So time, t, is going to be distance divided by velocity. So our distance is 1.3 over the 1.2 times 10 to the power 2, and that equals, putting it into the calculator, 0.00108. Now we can write this as 1.08 times 10, and this time we're going after the decimal place, 1, 2, 3. So it's, because after the decimal place we say minus 3. Okay. Just get rid of that. To find out where this layer is to get rid of that layer. Okay. Next one is going to be this. And so the apparatus used to find the effect of different sucrose concentrations on the rate of osmosis. So this is all about how to read a graph. And we want to use the graph to calculate the rate of osmosis in millimeters per minute, that would occur for sucrose concentration of 2.5%. So here is 2.5%. Why is my pen not working? Try this one. Nope. Okay, I'm going to have to get another layer. Okay, so here's our 2.5%. Still not working. Oh, that's annoying. Let us here's our 2.5% here. Now we're going to read up here and then get to our graph, and it comes in at this point here, and then we have to read along to find out the rate of osmosis in the millimeters per second. Now we need to know what these divisions stand for. So it goes from 40 to 50. So between here and here we've got 10. Now how many little squares do we have? We've got 1, 2, 3, 4, 5. So we need to know what one little square is. So we're going to do 10 divided by 5, and that gives us 2. So this comes up to the first little square, so that's going to be 42 millimeters per hour. Oh, so this is 42 millimeters per hour, and we want it in minutes. So this is something you really have to pay close attention to in these exams, is the units. They will so often in these questions go between two different types of units. So this is per hour, we want it for minutes. So how many minutes in an hour? There's 60 minutes. So we need to take our 42 and divide it by 60. So I'll just do it quickly in the calculator. So that's going to be 0.7 millimeters per minute. And that makes sense, because if it was 60 millimeters per hour, it would be coming at a rate of 1 per minute. So we think it must be less than 1. Okay, let us find the next one. Okay, so this is about ratios. So the diameter of a capillary is our capillary, and it's useful to draw wee diagrams. 8 micrometers, and the diameter of an aorta, this is the capillary, and this is the aorta, is 25 millimeters. So instantly we need to be aware, different units, and we're told that 1,000 micrometers is the same as 1 millimeter. Now we want the ratio between the size of the capillary and the size of the aorta. Now we need to turn this capillary, this 8 micrometers, we need to turn it into millimeters. So to do that we're going to divide by 1,000. So 8 divided by 1,000 is going to be this. So our 0.008 to the 25. And now we're going to divide both sides by 0.008. So it's a bit like fractions. And what we do to one side, we do to the other. So that's going to be 1. And dividing that, we'll get 3,125. So this shows us that the aorta is 3,125 times larger than the capillary. Right, let us get rid of... No, where's this layer? Oh, I can't find this layer at all. Oh, here it is. Okay, now this one. So this is about a rhinoceros horn. It's valuable in some cultures. And we're told that in 2016 there were an estimated 25,000 of one species of rhino left in Africa. We want to calculate the year which the rhino species will become extinct, assuming birth and death rates remain equal. Okay, so the first thing is if we've got one rhino is being killed every 6 hours. So how many per day? Now if you're not sure how to do all this question, look at the number of marks. There's 3 marks. So it may be, don't just kind of think I can't do it and run away from it. Try and give some information and then you get something for your work. So how many per day? And make your working clear. Don't just throw random numbers on the page. Show where, so the person marking it understands where you're coming from, understands where the numbers are generated from, and then it helps you gain these extra marks. So how many per day? So we have 24 hours in a day, and we're going to divide it by 6, because every 6 hours one dies. So 24 divided by 6 equals 4 per day. Now, we can now calculate how many die how many days it would take for all these rhinos to die. So we've got 25,000 species. If we divide them between 4, so every day 4 die, so we divide it into, if we were to group these together in groups of 4. Those groups, each first group down day 1, second group down day 2, until X number of days later there's none of these rhinos left. So we're taking all our rhinos and dividing them into groups of 4. And that gives us 6,250 groups of 4 rhinos. Now each of these 4 groups of 4 rhinos die of one group a day. So this means this number is the number of days it would take until there were no rhinos left. Now we need to find out how many years is 6,250 days. So we take our 6,250 days and divide it by 365, because that's how many days are in a year. And this gives us 17.1 years. So we're starting at 2016. And we're going to add on 17.1. And that gives us 2033.1. So it's 2033, but there's a little bit extra. So it's actually going to be in 2034. In the year 2034, there'll be no rhinos left. Okay. Oops, the wrong thing. For the next question. Okay. So BMI. This is how to calculate the BMI. And it's used as a simple calculation between the mass in kilograms and the height in meters, and there's a little 2 here, so it's squared. Now we need to pay attention again to our units. Kilograms, the mass is in kilograms here. Why is this not working again? Oh, that's working now. So this is in kilograms, which is good, this is what we want. But look here, the height is not in kilograms, it's in centimetres. So 165 centimetres is the same as, to go from centimetres to metres, we divide by 100. So it'll be 1.65 metres. Now we can do the BMI is equal to mass times the height squared, which is 60 over 1.65, and we square this, and that comes out at 22.04. Okay, I'm going to have lost the bottom of my graph here. Move it up. Right, let's just move that to here. And there's another, so there's another reading up there of 20 degrees at 2. I'll write that here, 20 degrees at 2. So, temperature in degrees C and the number of bubbles per minute produced in an experiment. I've cut off the actual what this experiment is showing, but I just want to show you how to do a graph, because there's always graph ones. So on a graph, it's important that we firstly we have to label our axes. So the bottom axis here is going to be temperature. And this is going to be bubbles per minute. Why is that not working again? It's being really glitchy. Okay, so we've got going from 20 to 55, 20 to 530. It's going up in 5 degree slots of 5, 20. So what we can 20, 25, 30, 35, 40, 45. That's not going to work. So we would need to do different divisions. So this could be 1, 2, 3, 4, 5. So we could do a thing where we start at a different. So that means that we're not starting at 0. We're going to start at 20, 25, 30, 35, 40, 45, 50, 55. And it goes from 2 up to, the biggest one is 20. So 5, 10, 15, 20. So if you've got space, 10, 15, 20, 25. Let's do that. So it's the bubbles per minute. Now, at 20 degrees, so this is 21, 2, 3, 4, 5. So we need to make sure you get to the right division on here. It's hard to see, so it should be on 5 squares along, and it's 2. Now, what is the divisions here? We've got 10 divisions, but it only goes up 5 degrees. So 10 divided by 5 is 2 blocks is going to be 2 squares. 2 blocks is going to be 1 degree, sorry. So here we're going to have 1, 2, 3, 4. So it's about here. It's not very, it's hard to see the squares. 25 is 6, so it's going to be, there's 6. 30 is going to be 8. Here. 35 is 10, so it's nice and easy. 40 is going to be 14. 2 below here. 45. I should have made it along here, sorry. It's gone off kilter a bit. 45 is going to be 20, so up here. We don't have anything for 50, and then 55 is 2. So we've got this graph, it kind of goes, oh dear, that's all rubbish. Like this, and then we would use that to now here we don't know if this goes up a little bit and down, or if it just goes down here. So we assume that it's just kind of dropping off. And if we come up to here, you'd get a rough estimate of where it is at 50. Obviously use rulers for straight lines, because if you're asked to read off a graph that you've drawn to get data, you are going to need it to be quite accurate, but they usually have a little range because they understand that it's not going to be perfect. But a ruler to draw straight lines is going to be better. I can't do that obviously on this, and it's hard to see the divisions. Okay, Let me get rid of all this. Find where that is. Where did that line go? There we go. So here we are with this one. So this here table shows the deaths caused in 2014 by bacteria resistance of antibodies. And this predicts the deaths going to be caused by 2050 caused by resistant bacteria. Calculate the percentage increase in the prediction of the deaths. So, now although this is 10 to the 6, you actually don't need to worry about doing this. You can just work with the decimals given and you'll be getting the same result because it's all just powers of 10. So first we need to work out the how many the deaths increase by. So we've got 10 million minus 0.7 million will give us that difference. What is the difference in deaths between 2050 and 2014? And that is 9.3 million. So 10 to the 6 is million. So there'll be 9.3 million more deaths between what was in 2014 to 2015. Now when you have a percentage increase, you have the difference. This is the same for a decrease as well. Divided by the original times 100. So our difference is 9.3. Our original amount was 2014 was 0.7 and then times by 100. And that's going to give you 1,328.6% increase in the number of deaths. If you had a percentage decrease, you would it would be a number less than 100. But this, because this is an increase, you're going to have over a percentage over 100. It's actually over 1,000, but it's a massive increase. Okay. And this is our final one. So this tells us heart disease deaths in the UK population per 1,000 in the population, and here's the age range, and it's split between males and females. We're interested in this, but this is the mathsy bit. The population in the United Kingdom is 65 million, of which half are male. Calculate the number of males with heart disease in the age range 18 to 44. So the first thing to do is note, this is the total population. Um, 65 million, but we're only interested in the men. So we need to divide that by 2, because roughly it's going to be 50-50 between men and women. So dividing that by 2, we get 32.5 million men. So all we've done is divide by 2. Now, million is 10 to the 6, so I'm going to write this up here. So it's 32.5, and then you just write times 10 to the 6 for million. Now we have between 18 to 44, we have 5 males per 1,000. Now this is per 1,000, so we need to divide this by 1,000. And that gives us 32,500. Now we need to take, this is divided by 1,000, sorry. And so we take the 5, multiply it by 32,500, and we get 162,500 men will have heart disease between this range. So again, this is a 2-mark question, so you need to just pay attention to the little bits, things like making sure you divide through by 2. There's all these different, if you can get something, even if you can't get to the full answer. And then you've got this important bit of recognising this is in per 1,000, and so changing this into the 1,000. So it's these little things just to keep an eye on when you're doing these questions, to help you along your way.